Hi everyone, welcome back to Code Overdose. Today, we're diving into asynchronous programming with async await keywords and exploring the differences between ToList and ToListAsync. Before we start, don't forget to subscribe to my channel and turn on notifications so you can get my latest content as soon as it's available. Now, let's get started. Let's start by understanding what asynchronous programming is all about. Asynchronous programming is a way to execute tasks in a non-blocking manner. This means that while one task is waiting for a result, other code can continue executing. This is crucial for improving the responsiveness and efficiency of applications, especially those that perform a lot of I/O operations. There are three key concepts to grasp. Non-blocking. Asynchronous operations allow other code to run while waiting for a task to complete. Imagine you're waiting for a file to download. With asynchronous code, your application can keep doing other things instead of just sitting idle. Concurrency. This concept enables multiple operations to happen at the same time. It's not just about waiting. It's about doing multiple things simultaneously, which can lead to faster and more efficient applications. Task-based. In C#, asynchronous operations are often represented by tasks. A task represents an ongoing operation and can be awaited, which means your code will pause at the await keyword but won't block the entire application. To implement asynchronous programming in C#, we use the async and await keywords. These keywords help you write code that can perform tasks asynchronously, making your applications more responsive and efficient. Now let's compare ToList and ToListAsync, two methods commonly used when working with collections in C#. ToList, synchronous operation. ToList is a synchronous method, meaning it blocks the calling thread until the list is fully created. ToListAsync, asynchronous operation. ToListAsync is an asynchronous method designed to operate without blocking the thread. ToList blocks the calling thread, while ToList is creating the list. It halts the thread it's running on. This can lead to unresponsive behavior if the operation takes time. ToListAsync, non-blocking. This method allows other tasks to run concurrently while it's fetching data. This is especially useful when you're dealing with I/O-bound operations like database queries. ToList. Use in non-I/O-bound operations. It's best used when you're working with data that's already in memory and you don't expect any delays. ToListAsync. Ideal for database queries and I/O-bound operations when fetching data from a database or performing network operations. Using ToListAsync helps keep your application responsive by not tying up the main thread. In summary, if you're performing operations that might take a while, especially involving I/O, go for ToListAsync. For quick operations where blocking isn't a concern, ToList can be sufficient. Now let's demo to see the difference between ToList and ToListAsync. In this example, I already have app.db context using Entity Framework, and it has one model, which is a product list. You can see that when the model is created, it will generate 100,000 records of products for testing. I also have a product component. First, I will declare a list for products and a variable for the message. In the UI, I will have a button for Load Product Synchronously, and another button for Load Product Asynchronously, and I will show the message, then use a for each loop to display the product list. I will define the function loadProductSync. First, set the message to loading text, then call dbContextProductsToList and inject dbContext. Afterward, set the message to loaded text. The function loadProductAsync will be similar. It will set the message to loading, get the products by calling await, dbContext, products, ToListAsync, which will use the Entity Framework core namespace and then set the message to loaded. Now let's run the project to see the difference. Go to the product page, where we have two buttons. Click the Load Product Sync button. You can see that it does not show the loading text. Instead, it displays the product list and the loaded text. Let's reload the page and click the Load Product Async button. You will see that it shows the loading text immediately, then displays the product list and the loaded text. So why does using ToList synchronously not show the loading message, while using ToListAsync asynchronously does show the loading message? Because when you use a synchronous method like ToList, it blocks the current thread until the operation completes. The call to ToList blocks the main thread, the one handling UI updates, while the data is being fetched from the database. During this time, the UI cannot update because the thread is occupied with the data fetching operation. As a result, any UI updates, such as displaying a loading message or spinner, are not rendered because the thread is busy with the blocking operation. The UI appears unresponsive or frozen. When you use an asynchronous method like ToListAsync, it allows the thread to be freed up while waiting for the data to be fetched. This means that the UI thread is not blocked and can continue to process and render updates. Because the UI thread is free, it can process and display the loading message or spinner while the data is being fetched. This ensures that the user receives feedback that an operation is in progress, improving the perceived responsiveness of the application. And next, I will show you how to improve performance with asynchronous programming. Assume that in the load product async function, we need to load a lot of data or perform an I/O operation where we can benefit from asynchronous execution. I will define a function loadList, and let's assume it takes about 2 seconds to complete. When it completes, it will show the loaded message and call state has changed to re-render the UI and display the new message text. Then I will use a loop to call the loadList function 10 times. Let's run the project to test it. In the product list, click Load Product Async. You will see that every 2 seconds, it shows the loaded text sequentially. This takes a lot of time to get all the data. But if these lists are not related to each other, and we don't want them to run sequentially, how can we make it faster without waiting for the previous task to complete? Here's how we can do it. First, we define a list of tasks. Then, in the loop, instead of using await, we just add the task to the list. After that, we can use awaitTask.whenAll and pass the list of tasks to it. This way, the tasks in the list will run simultaneously, and the whenAll function will wait for all tasks to complete before continuing. Let's hot reload and check it. Reload the page and click Load Async. After a few seconds, you will see that all the lists are loaded, and they don't follow any particular sequence. You can see that the messages are loaded out of order. This approach allows us to run multiple tasks simultaneously, improving your performance. That's it for today's video. If you found this explanation helpful, don't forget to like, subscribe, and hit the notification bell for more content on programming and technology. Leave your questions and thoughts in the comments below. Thanks for watching, and see you next time.